I'm sorry, I got back here. I don't know what happened. Probably my internet decided that I was too harsh on the internet and on Olena as well, and decided to give her a break. Anyway, coming back to where we were, I'm really sorry for torturing, but this is a necessary evil. You have to go for necessary evil. So the necessary evil is that if we take the average by first axis, you get 2 values. If I take the average by the second axis, I get, Simeon, how many values?
3 values.
You get 3 values. And if I take the average of by the second axis, which is third in real life, how many do I have, Oleg?
To be honest, I have no clue.
6, because I tried.
6 values, exactly. You get 6 values, and in fact, these are the predictions themselves. So that's basically
It's
the
average
original.
of every element.
Yeah, average of every element in that sense. Now the final question: what should I type here? Which axis? Lena, and this is the question that I want to return back to you. Which one should I type to formulate the ensemble predictions of these 3 linear regressions?
The last one.
So I get 6 values. How many test points do I have?
2.
2. So how many values do I want?
2.
So what is it that I should type? Give you a head start. So I say that if I take by the 0 axis, I get 2 values.
Mm-hmm.
If I take by the first axis, I get 3 values. If I take by the second axis, I get 6 values.
Okay.
Okay. Yes. Yes.
Mm-hmm.
Good.
So what's the name of this axis that we just are using? It is which?
But there is no name.
Oh, but I mean, it is the axis of. I have no.
This is axis of points, basically.
And the points are.
Test points. So we have 2 test points, and this would be the prediction Y value for each test point. Basically, that would be the thing. If we would take it for the second axis, it would be by the model, average out by the model. So there are 3 models. And if we would take it by the third axis, it would be by prediction each model, like every value.
So prediction. So the choice was prediction divided by models, prediction divided by all the predictions, or this what we chose, which is prediction divided by what?
So we take 3 model predictions.
Yeah.
For a point, and we just take the average of these. You take the prediction of the first model, second model, and third model for the first point, and you average them up. You take predictions of all three models for the second point, you average them up.
Yes. And then, but when you say like by the axis, we're just trying to identify which of these inside this matrix of, or a tensor of things, which is the column that that corresponds to the predictions.
Usually it means that you need to find the one that gives you the correct number of things. So if you're expecting to get 2 predictions for 2 points, then you need to try different axes to get exactly the same, this number of. And of course, you can just print out your predictions. You can say, okay, these are the predictions for my first point. If I take the average of these, would I get 3.31? And if I take the average of these 3, do I get 4.89? If yes, then that was the right axis by which I should average. Okay, always try to use this when you aren't sure how to proceed. Think about this divide and conquer method. So you make a smaller problem, you solve the smaller problem, you divide it into smaller pieces, smaller problems, and then you solve the smaller problem and then check out what's the result of the bigger problem. All right, so now that we have a prediction of our ensemble, what we could do, we could just take we could calculate the RSS of this prediction as the same way we have calculated RSS for each individual model, right? Here we had the predictions generated by each individual model, and then we calculated the RSS, the metric, the performance metric of each of the model predictions, right? And then Kenneth said that the ridge regression performed the best and loss of regression performed the worst of these three, right? So now what we could do, we could just go on and proceed to calculating this metric for the ensemble predictions and see if this ensemble prediction metric is better than any of the individual models, right? This would be the next logical step to do, to see if the ensemble actually performs better than individual models. But my question before that would be, what would you guys expect? What would be the expected value of the RSS? Oleg, what would be the expected value of the RSS? Looking at this, yeah, looking at these RSSs here, if I ask you what would be the RSS of the average of these models, what would you expect?
Less than 1.
Okay. Simeon, what's your take on this?
Yeah, I think it will be close to average of these figures.
No, it should be less than 0.6, I think, no?
Yeah, so I think what I meant is that basically, could you tell me the function which I should apply to these three figures to get what I expect? And I think Simon, in that sense, right, I can take average of these RSSs to expect something, right? So I can take just these three values here in each of these variables. Igor, what are these? So I have LR RSS, I have LR ridge RSS, and I have LR lasso RSS. I take the mean. Olena, do I have to write axis here? Should I specify axis by which should I take the average, like we did here before?
Oh.
No, because there are individual values. There are no, these are not vectors, so it doesn't really matter. There are no axes. So I could just write NP mean and then all of them three, and that would be enough. I think what I need to do, well, let's see. I'm not sure if this works. Okay, this doesn't work. Why doesn't work? Why doesn't work? Why it doesn't work?
I do not know why it doesn't work.
Okay. Oleg, you're the Python expert here in the entire call. What is the problem?
Because we need to put it as a list, yeah, square brackets.
We should put it as a list to the square brackets, and then it's gonna work. So that is you can see that is the problem with Python. So you can always, you should always operate on top of some kind of list or NumPy array, whatever have you. So this is what the average RSS value would be, right? This is what be the average RSS that would we expect. And now what's the real RSS? What's the real RSS of these ensemble predictions? We take these ensemble predictions, we put them into RSS function, and this is what the real RSS. Lena, what is the, what are your interpretations? What is it that you think when you look at this value?
Different values, like, I don't know, we have different.
It's different from what we expected, right? It's different from what we expected, for sure. Is it better than individual models?
Sure.
Who was saying? I couldn't hear.
Me.
If we compare to individual models, right? These ones, it turns out that the ensemble performs better than the best model that was the individual model, right? Which was the ridge regression. So the ridge regression had RSS of 0.61, but our model performed with RSS of 0.47. The RSS, just to remind you, the lower the RSS, the better the model, okay? Ladies and gentlemen.
Yep.
Does this make sense? Okay, Lena, ask questions. I can.
How we can get average 0.4 if we have 0.2, okay, 1, like 0.6 and so on?
That's a very good question. And in fact, if we take the average of RSSs, here we are. We'll have actually 0.92. This would be the average RSS of these three models. But if we take the ensemble and we take the RSS of the ensemble, it turns out that the ensemble's RSS is 0.47. And the thing is, it turns out if you look at the, if you look here, then, and you think about the predictions of the points, not the, so what is RSS? RSS is the average distance, is a squared distance from the prediction to the real point, right? So if you take the RSS of the blue point, a blue line and the blue point, this will be this distance squared, plus this distance squared, right? This would be RSS for the blue line and test set. The same would be for the red line and dashed line. But when we generate the average predictions, we then take the squared. And so I think it would make sense to draw it, but I guess I don't have a way to draw it right now. But basically, when you take average predictions, they tend to be closer to the points and the distance gets smaller. And that's why when you take a square of this distance, it turns out to be much lower than the average of RSSs. If that makes sense, because there is the square with function that is involved into the process, and it's not linear; it's squared. So when you make the distance from the prediction to the point smaller, then the error gets way smaller because of the square function. Okay, that is the point about this. RSS is the specific function which looks at the square. Kenneth, is it clear?
Yeah, it is. The thing I was going through my head was that, I mean, just by eye, it looks like you might get a better result if you only do ensemble with 2 of the 3 methods. Because lasso seems to be like the least best fitting.
Oh, but in this very specific case, it's pretty good, right?
I guess so.
Yeah. Simon, Oleg, are you guys following this explanation?
Mm-hmm.
Mm-hmm. Igor?
Yes, I mean, but that's the question why we just took mean of RSS of all 3 models, because this will definitely show us anything. Because our assembled model should be like less than 0.6 as our best model for the 3 models we are performing.
It's not guaranteed that this will be lower than the best individual model, but it normally happens like that. We took the average just to get a feeling of what we could expect from these models. This was just to get a feeling.
Yeah,
I would say that we need to go on to the other parts. Wait, I got lost now. Yeah. The next cell here does some magic that I suppose we will do a bit later, so I won't explain it. This I'll just show you what it does on the figure. It produces the line of the ensemble. This is the ensemble predictions. This is the linear model, which is an ensemble of 3 linear models. So if I would take the predictions from each model, and then I would average them up, then this would be the ensemble. This would be the ensemble. Okay, the purple line is the ensemble. Make sense?
Yep.
Okay, cool. Yeah, it was. We spent quite some time on this, but I guess it was. I hope that this was worth it. Now there is an example with a classification. So exactly the same stuff. Basic ensemble, we are majority vote with the classification. For this example, I need to generate synthetic data. So I generate synthetic data with a random seed. You guys remember what random seed is to reproduce the your work, so that you all guys, when you run it in your notebooks, you get the same data as I do. This is why I have this random seed. Why is that kind of random seed? Don't ask. It was just whatever. I generate a synthetic data set with 2 dimensions and 100 points per dimension. So per class. I have 2 dimensions and I have 100 points per class. I have 2 classes. And here I do something that is called sampling from multivariate distribution. I'm just basically generating random points. I'm just generating the random points using distributions that I define here. These are the averages of these distributions. These are covariances of these distributions. You don't really need to go into all these maths to understand it. I just generate synthetic data. Here I just generate 100 points from the first class, and here I generate the 100 points of the second class. The only difference is that the distributions of the second class is centered on 1s, and the first distribution is centered at 0. That's all there is. That's all the difference there is. Here I concatenate both samples, 100 points from one class, 100 points from the other class. I concatenate them, I glue them together into one training data, into one data set. I make a data frame. I assign names to each column. So I have 2 columns. I assign names X1 and X2. This is just to make it more flexible so that I can make a 50-dimensional data and so on and so forth. I create a class column, meaning that I know which data points come from the first class, from the first distribution, and which ones come from the second distribution. Then I make it categorical here. So I just say that this is these are classes, these are not values. And then I break them down into train and validation sets, okay? Do you have questions about this? It's a bit kind of complicated, but this is setup code. It's not something that you would need to write yourself. Okay?
And the data set we're building is for two item classification, right?
Yeah, this is a binary classification problem.
So make two random distributions, shift them apart, and take some 100 points from each one. And here I visualize them. I actually make a function called draw points ggplot2 that, given a point set, a data frame with the coordinates and class column, would actually visualize them. So I can tell them, okay, here's my train, visualize my train, and it will draw a picture like that. Okay? And then I would say, hey, here's my validation, and please visualize my validation. And that will draw me a thing like this. And you can see that there are more train points than there are validation points, right? The validation is a bit less numerous than the train points. And you can see that they do overlap, right? There is, so there is a variance. Points are scattered. So they kind of overlap, but there is still, if you look at the concentrations, then the concentrations are a little bit shifted. Okay.
and they are shifted by diagonal, right? Because the x1 and x2 and so these ones have the center here. The red class comes from from center of 0 in both cases. And the blue stuff, it comes from a center somewhere here at 1, 1, right? So this is the center of the blue class. And then they're scattered around. So there is some scatter. What I want to do is I want to build 3 models. I load them from scikit-learn. I say from scikit-learn tree, I want a decision tree classifier. From scikit-learn neighbors, I want the k-nearest neighbors classifier. And from linear model, I want the logistic regression classifier. I will not explain right now what logistic regression classifier is. Not that I think that you guys remember it by heart and can write up the formula, but I don't think it's important. I can actually, I can import some other classifier, which I don't know how it works, and it still would apply because we are looking at ensembles which operate on top of the regular machine learning algorithms here. So it doesn't really matter what kind of machine learning we are using here. These are the templates. We generate 3 templates, model 1, model 2, model 3. From each one of the classifiers, and then we train them. I guess I should have added a little bit more of the self-writing code here. But I take my train data. I say that I want to have x1 and x2. These are only dimensions that I have. And I train them against my class, right? This is what we have done with, basically, this is the same thing we have done with regression algorithms before. But I do it for model 1, model 2, and model 3 separately. And then I use these models to predict class value of the validation set. Ladies and gentlemen, does this cell make sense for you? Does it make sense? Olena, do you have questions about this one? Does it like looking at this sounds reasonable, looks reasonable? Can't hear you. Somehow the microphone is somehow.
Here.
Sure, sorry, probably the accumulator got tired of the headphones.
So how we decide which classifier
models to choose? Yeah, it's a good question. So how do I know which models should I choose as part of my ensemble? And what I say usually is that try to use conceptually different things. This is what I've done here. I've chosen conceptually different things. I kind of know what logistic regression is. I kind of know what nearest neighbors classifier is, and I kind of know what decision tree classifier is. And I know that they have a very different ways to construct the model. So the decision tree is building splits, and then by splits it decides which bucket each point goes and that kind of stuff, and it decides the class by by what kind of points are in the bucket. K nearest neighbor finds the closest neighbors and decides the class based on the closest neighbors. And logistic regression uses an approximation function on which it actually projects points, and then basically based on their location on this curve, it decides on the class, essentially a linear classifier. So I think these are essentially mechanically different approaches to classification. So I chose these 3, yeah. But there is no silver bullet. There is no strict rule how you decide which models you choose.
Can you use
it's always
5,
sorry?
10? Can you choose?
Oh,
5,
number.
10?
So there are some caveats. The more classifiers you choose, more robust your performance. But also you need to remember that more means that it takes more time to train. For example, you probably remember that K nearest neighbor is very slow algorithm, it takes ages to train. So more you choose, more you will wait. Also harder it will be to understand what the model does. I'll talk about the interpretation a bit later. But normally more robust your performance. there is another caveat is that when you choose odd number versus even number, can you guess what's the problem with the even number of classifiers?
I mean, you're asking for ties. You want to have no tie.
Yeah, I don't want to have ties. That's why I usually choose odd numbers. So if you would choose 3, 5, 7, 9, and so forth, you would normally not have ties if you are dealing with the binary classification. If you're dealing with multi-class classification, nothing saves you from ties. And we will talk about ties in the future. We will see what should you do with the tie.
How it's translated, ties?
Ничья.
Okay.
So the tie is when you basically have four classifiers, and 2 say that this is a dog, and the other 2 say it's a cat. And then whom you trust, right? Who is that you trust? Yeah, that's what tie is, and that's what a draw is. Any other questions about this cell? Does it make sense? Does it look reasonable? If I ask you to initialize classifiers, train them, and predict on validation set, you would be able to just write it from scratch yourself by copying this cell.
Why we do not use here test set?
Why didn't I use test set? It's a very good question. I consider this validation set here as something that I will still use as part of my hyperparameter tuning later on in the class. So I wouldn't dare to call a test set because I touch it too often. So I would call something a test set only in case I would touch it once and never again. So this is definitely not the test set. Why didn't the another question that you can ask is, why didn't I create one? I mean, I have been synthesizing data anyway, right? So why didn't I create a bit more data so that I have enough data for a test set? Well, the truth is, I plan to show you how you can use only validation and train data to estimate the performance of your model without the need for the test set. Test set is usually a very expensive thing to have. It means that you may not use this data for your training, which is unfortunate. In terms of data, it's very unfortunate. Usually, very often in business, you don't have, I mean, in business, you may have enough data, but normally we care about data. We care to the extent that we want to use it as much as possible for training and not so much into kind of validating our models. So we are trying to make use of data as the best as we can. So that's why I'm not using test set here. I plan to show you how to estimate the performance without using test set. Any other questions? I just had a comment that in most of the exercises in this homework and in the previous homework and in the future homework, what you will have to do is mostly look in the other cell's code and copy the relevant parts. Most of the time, what I'm expecting is just to find a cell which has the same code or similar code and just change the names of the variables, okay? Most of the time. So I run this. Now I need to generate the ensemble, a majority vote ensemble. So what I mean by this is that if I look at the validation data frame and I can use a function head, I will see that I have variable 1, which is my independent variable, the second independent variable, and class. This is my true class, okay? Ladies and gentlemen, this is my true class. And then I have predictions by model 1, 2, and 3. In this very particular case, they all predict that this is a class 0, but in fact, it's class 1, doesn't matter. So what I want you to do in here is I want you to create the new column called ensemble. And in this ensemble column, I want you to have a value of a majority class of these 3. And you can use a function called mode. So there is a function called mode, which you can use for this. Give it a try. Give it a try yourself. Try to do it yourself. And raise your hand if you have done it. Challenge yourself. Try to write it yourself. Use all the tricks that we have seen so far. Try to print small things. Use this divide and conquer. Do it yourself. Try to do it yourself. You can refer to every model prediction using vol square brackets model 1, for example. Another thing is, another way is to say model 1 and then comma model 2 and then comma model 3. So sorry, I need probably double brackets. Yeah, so this is another way to get your pandas outputting only values of these three models. And then you can do some additional functions, for example, sum or whatever have you. I think I gave out all the code right now, almost. Raise your hand if you have done it and if it works for you.
Bound method.
Don't forget to raise your hand like this. You can click on raise hand and then you will have a raised hand. And you can lower your hand. Usually I'm host on these kind of calls. Okay, Kenneth, I can see it. Thank you very much. That's also reactions. You can have reactions, I think. I'm not sure I have reactions, but can't see reactions. So hosts on Zoom calls cannot raise hands. If you're a host, then you're out of this beautiful functionality. Anybody else? Igor, are you back on coding?
Yes, I'm trying to use this mode function, but actually I don't know why it doesn't work.
Mm-hmm. Okay, but give it a bit of try, and then we'll tackle it together. Olena, are you approaching?
I don't know how to test it.
You can test it here. Just create yourself a very safe environment, pressure-free environment, and then just do whatever you like. That's why I like coding, and that's why I like Jupyter notebooks. You can create a cell, and you can write an artificial intelligence here, like a general artificial intelligence in one cell, just for fun, and just run it. But just make sure that it can't invade other computers and the network. Otherwise, it would be the end of humankind.
Got it.
Simon, are you approaching?
Oh, his hand is up.
Your hand is up. Ah, oh, Kenneth, Simon, okay. Oleg, how about you?
Sorry, I was
Got you attached.
yes.
Okay, okay, no problem, no problem. Get back. All right, so well, so what I would do, I would use this kind of notation. So I would output. So this is the way to address all three model predictions, right? I would do it like this. And then when you type dot, you can actually use some function. For example, function mode, right? If I type mode and then brackets and I run it, it will give me this, which is just one row. What is this? Kenneth, what is this?
It's average of the wrong axis, I guess. The average of
Yeah, it's a mode of the wrong axis. So what mode function does, it takes the majority class, right? So if you have, basically there are more zeros in by each model, produced by each model. So each model by mode produce 0. So what should I do to make it right, to make it work the way how I wanted to make to work?
axis equals 1.
Axis, and then let's imagine I haven't heard Kenneth. I was like, what are you saying? You're saying I can't hear you. So I was like, we tried 0 before. Why wouldn't we try 0 again, right? Kind of makes sense to me. Why not? Oh, but that gives me the same stuff, right? What if I try the next thing, which is 1? Oh, and what is this? I have 80 rows with 1 column, and the first lines look very reasonable. This is what I was seeing when I outputted just the predictions. So I would say that mode for this first row should be 0, as well as for the second and third. For the third row, what would be the majority vote? Igor, what would be the majority vote for the third row?
0.
0. What about this row?
1.
1. So it goes like this: 0, 0, 0, 0, 1. So if I put it back and I run it, 0, 0, 0, 0, 1. Sounds like what we needed, right? Did you guys manage this? So I just copy paste it in here and I run it. Olena, did you should I send it to Slack or chat so that you guys don't have to copy it over? I mean, you can go to my notebook and copy it, but otherwise, does it make sense to copy it to chat? Lena? Anybody?
Can you use mode and inside brackets mode put value of 3 models?
I think this mode is a pandas mode, so it works in a very specific way. I guess you could have used mode from NumPy. I think so, but I haven't tried. So maybe, yeah, we could try. So if I take, I would take it like this, and P maybe mode, and then maybe something like that. It says has no attribute, so then I would use PD mode, which is pandas. It has no attribute mode. Then I would say mode Python. Oh, let's give us some. It needs statistics, right? So it needs statistics. Statistics is another package called statistics. So what we would do, we would need import statistics. Okay, and then I would need to write statistics.mode, and then it would say no unique mode, found 3 equally common values. So I would probably need to write something like I'm not entirely sure what would I have to write.
It's a mode.
Statistics is from. I did the same exercise, so statistics should be imported from SkyPy. So you need to write the import SkyPy and statistics, and then all the code. So I did the same, but I didn't get the result. I don't know why. And actually, your one line of the code looks more.
Let's see. I mean, so Pandas has its own mode. That's fine. But then what if you want to use mode from statistics on Pandas? Can this be done? So I start looking like this. This is what I normally do when I look at these kind of things. And then I look for mode. Yeah, so basically it starts saying that this is the way how you get mode from Pandas. I would say let's focus on this and use this kind of notation. I think it looks a bit simpler and doesn't require additional packages. All right, so now if I would print out the validation head, I would basically see that now we have an ensemble column. All right, we have an ensemble column. So we have predictions by ensemble, majority vote. What we could do now is we could first we could assess. We could basically evaluate each model, each individual model. So the function score takes the validation data, compares to the validation class, and outputs accuracy. In the case of binary classification, it gives me back accuracy, 0 point something. Then I multiply it by 100 to get percentages, and this is what I get. Basically, what it's saying is that accuracy of the decision tree is 70%, nearest neighbor classifier 72.5%, and logistic regression is 73.75%. Does this make sense, ladies and gentlemen? Do you have questions about this?
Yeah. No, it makes sense.
Okay. Okay. Lena, does it make sense? Okay, so Igor? Okay, good. Now,
and score, what does it mean score? How it's calculated inside?
So I will, right now, I'll ask you guys to calculate the score yourself. The problem is the function score is working only for the scikit-learn models. Since our ensemble was produced not by a scikit-learn object, we have calculated it ourselves. We don't have a scikit-learn object with a method score that can take validation data. And then basically, you know what? I think it makes sense to calculate and see how it works. Okay, let me try together with you. So together with you, I have nothing in my sleeves. I completely basically open to all of you. So what we do, we take, for example, let's calculate accuracy of the decision tree. I take my validation data. I take model 1, which is a decision tree. So these are, Igor, what are these?
These are like outputs of the model 1. So line 129 is supposed to be 0 according to model 1.
Exactly, which is a decision tree. So these are the class predictions by the decision tree of the validation set. Now my question is, let's leave that alone for now. And what is this? Lena, what is this?
It's our original data classes.
Yeah, these are original data classes. So what if we compare the predictions made by the model number 1 and the regional data classes. How can we compare these? So just follow me on this. So I take validation model number one, and then I have to do something to compare to the true classes. Okay, so these are the true classes. Okay, these are the predictions by model number one. So what should I put in here to compare them?
If they are equal, it's good. If not, that's wrong.
Yeah, so what is it that I should type here?
Is equal to or something.
Huh?
Some kind of some comparator is equal to, or
Equal to. For example, how do I type equal to, Elena, in Python? How, so if I, okay,
Two equal signs.
4, so how do I know if they're equal?
Two equal signs.
Yes, I've heard that. Thank you very much. But I just want to make sure. So what happens if I type equal, just equal? 5 equal 4. Igor, what happens if I type 5 equal 4?
I think there will be an error because we need to type double equals just to make.
Wait. Okay, I got it that we need to write double equal. Thank you, Oleg, for reminding me two times. But I just want to know what happens if I type 5 equal 4.
You name 5 as 4, like you're.
I tried to assign 4 to 5.
Yeah.
I tried to make a variable 5 and try to make a value of the variable 5 equal to 4. And I think Python will not be happy with this. Well, hopefully. This is a nice news that Python is unhappy with this. Then if I type equal, it means that I'm asking a question whether 5 is 4. That the value of 5 is equal to the value of 4, which is hopefully is not correct, which is false, right? So I get a Boolean. It turns out that I can do the same stuff with lists. I hope. I'm saying it so confidently. I don't know actually. So if I say 5 and then 3, would this work? Okay, no. I can do it for the NumPy array for sure. I can do it for the NumPy array. Then I could do it like this. So if I would do it like this, then this would be this. What about that? Yeah. Hooray! Now it does it by element, right? Now, if we are getting back here, if I type equal, Lena, what do I get? What's the result of this operation? Look at this line here. What did I get?
Okay, here's to this question. Like you try to compare, I don't know, 80 rows. So you need to compare each rows.
So just to iterate over this one, I got false after comparing first element of the first array with the first element of the second array. I got true after comparing second element of the first array with the second element of the second array, right? What do I get here?
I don't know, true, false, true.
Yeah, how many?
80.
80, right. So what would be the false? How can you interpret false in this result? When I have 80 falses and truth, what falses stand for?
0.
No, not exactly. I mean, I understand why do you say 0, but I just want to know when I compare predictions of my model number 1 with the classes, what false would stand for?
A wrong prediction.
A wrong prediction, and the truths will stand for the correct predictions. Do you guys understand that?
Yep.
Good. Lena, do you copy?
Mm-hmm.
Sure? Oh, the peer pressure. Kenneth said yes. Igor was making this, he was nodding and Simon was nodding, so it must be clear. Or you want to say something? You want to ask something? Okay, too much peer pressure. Now that I have mentioned that Simon has also noted and Igor noted, and how can I say that there are questions? So I can just do it. What if I want to calculate how many truth I have in this row? Igor, what is it that I need to do?
I don't know, maybe try to sum them up and they will automatically convert into 0 and 1s. And
Exactly, exactly. You know what, if I type, in fact, if I type NP array and like this, and then I say D type, and then I say something like, what is it? uint 8. Okay, it doesn't know that. Oh, I need to probably put it into this. Gosh. Anyway,
I think
there is a.
It's not you. It's just int.
It's just int. No, I think there's some problem with the. Sorry, this trick didn't work out, but I can use this trick. I think it still works. Oh no.
Could we assign a new value, the 1, 0, to whether it's correct or not, and then?
Wait. This is now getting personal. This is getting personal now. I'm just. No, it's fine. It's fine. I could just say NP sum and then that's it. So what is 56? Simon, what is 56?
True positive plus true negative.
This reminds me of the beginning of the lecture when Simon, just by looking at the graph, he was like 3.2. But can you put it into words that I can understand?
Okay, so this is a number of events when we predicted correct class.
Yes, correctly guessed class, correctly predicted classes. So this is how many times we correctly predicted class with the model number 1. How do I calculate accuracy? Ladies and gentlemen, Oleg, I think I can, this is a time to call for your expertise. How do I calculate accuracy from here?
Divide number of true by total number.
Lena, can you see where this is coming? Where this is coming? What is Oleg saying? That this is number of times we guessed correctly, and the accuracy is this number of times we guessed correctly by overall number of points in the validation set. So I should divide it by, yeah, by the way, how do I know? I know this is 80, no, for sure, but how do I programmatically say that it's 80? Programmatically say that it's number of points in the validation set. How do I know?
Len.
What is it?
And I forget.
Well.
Well, right?
Wow, okay.
Ta-da! All right, ladies and gentlemen, can you see and check this? How do I get percentages? Jenna, how do I get percentages?
This multiply.
500. Now that you know how to do it, please calculate accuracy for the ensemble yourself, all by yourself, alone. Absolutely, nobody's gonna help you. We have done it for the model number 1, which was a decision tree. Now, can you please do it for the ensemble? Remember that ensemble is in the column named ensemble. What's the accuracy of the ensemble? And we have approached the second break. So let's solve this one and go for a break. I think, Alexander, I think that was a useful idea to have this session split into two, so that tomorrow we'll have a second part 2 of the same. I can see that it makes sense to go a bit slower with the code and make sure that everybody is catching up.
Yep.
As soon as you know it, shout. Just shout it.
76.25.
Yay! 76.25. Simon, I hope you actually did coding, because today you have a very supernatural abilities. I wouldn't be surprised if you just looked at the code at like 76.25. That would be absolutely normal for me. Lena, where are you? Igor, where are you with that? What's up? What's up? What's up?
In the middle of the nowhere. It's okay.
It's the middle of nowhere. I love that. Do they say what's the accuracy in the middle of nowhere? They're keeping this as a secret. But what happened? So what should I do? Semyon, what should I do? Or Oleg, what should I do? Kenneth, what should I do? No, go ahead. Shoot.
We need to again to sum up all comparison between ensemble and true class values. Yeah, just to see which of them are true, false. To sum up all true, and then again divided by total number of measurements.
Yeah. So I just copied this one. Thank you very much, Oleg. So I copied in here. So I copied inside the curly brackets. I probably missed to explain this part. So the curly brackets is the part where you were supposed to add stuff. The curly brackets is what you can insert code, and it will be the result of the code will be printed out inside the string. Okay, that's where I would expect you to copy this line here and change model 1 into ensemble. Okay, that's all it takes. That's all it takes. Model 1 into ensemble. It would take just another column with the name ensemble, compare it to the real class, take the sum, number of truly guessed instances, divide by the number of all instances, and multiply by 100. And go for a break. And let's get back here at 12:16. Or ask me questions.
Okay.
Lena, how are you?
Почему у меня 52%? Что пошло не так?
А у тебя вот так?
Зашарь экран и покажи.
Зашарь экран и покажи. Слишком много хотите в 5 утра.
Low privacy, no privacy.
Ты еще можешь упростить и min взять, вместо того, чтобы делить на количество observation.
Так, ну что у тебя?
Вот это?
Так, validation ensemble, так, sum. По-моему, ты взяла сумму по средним, нет? Так, сейчас. Скобочка нет, там закрывается вроде бы.
Сейчас я должна найти.
Слушай, а может быть, ты как-то создала ансамбль не очень правильно?
Похоже на то. То есть ансамбль посчитан как-то по-другому.
Пойдем посмотрим, как ты ансамбль посчитала. Вот же ансамбль, да, вот так считается. Окей. А вот что ж ты его не присвоила?
Потому что я пыталась сделать через странный пакет статистики и что? Ничего.
Да, вот теперь запусти это. Ага. И теперь вот здесь запусти. Е-е-е! Счастье! Все, иди немножко отдохни и через 8 минут вернемся.
Okay.
Ты все остальное понимаешь?
Глобально, да, наверное. Или смотря в плане чего понимаешь?
Ну, глобально ты имеешь в виду суть ансамблей, ты понимаешь, что мы там только что. Ну, то есть там на самом деле мы ничего такого, только среднее. Ну, детали. Я все-таки про детали, потому что важные детали тоже.
Знаешь, типа, мне кажется, это тот момент, когда пока тебе все рассказывают, все понятно. Потом, когда ты начинаешь, ты, типа...
Да, знаю. Ну, в этом суть, да, суть обучения. Что сначала тебе рассказывают, все понятно. Ну, да, я постараюсь немножечко давать больше чуть-чуть сейчас челленджей, чтобы вот вас немножко почелленджить. Было, чтобы вроде как и понятно, и непонятно. Чуть-чуть было где-то там.
Знаешь, ты, типа, ты иногда вроде как бы не хочешь задать тупой вопрос на тему, но иногда, наверное, приходит, ну, как бы, я иногда не знаю, как далеко все функции работают. Нужно мне зайти и посмотреть, что она делает.
Я вообще не помню, как эти функции работают. Все, что я делаю, это создаю новую клеточку и туда. И вот там по 20 раз одно и то же, вот пока оно не даст того, чего я хочу. Но единственное, что для того, чтобы так делать, надо понимать, чего ты хочешь. То есть, что ты хочешь в результате получить от этого. Если ты знаешь, что ты хочешь, например, вектор такой-то длины, значит, у тебя... А это само по себе уже может быть проблематично, потому что тебе надо уже знать, куда ты хочешь идти. Когда ты еще не знаешь, куда ты хочешь идти, и ты используешь функции, которые ты не знаешь, вот тогда проблема настает. Вот потому что...
Окей, ты потестишь, но ты не понимаешь, что как бы в итоге ты правильно что-то делаешь.
Да. А ты должна понимать, чего ты хочешь увидеть. А тогда ты можешь уже там набирать случайные комбинации, и в какой-то момент увидишь нужную.
Угу. Ну, да. Да.
I'm sorry. There's some problem with my... I think it's just like, at some point it decides that I have consumed too much internet, so it's just like, okay, let's stop this guy because it's just too much internet. Conspicuous consumption. Okay. I was just about to ask if anybody has any other questions, burning questions. Do you have any burning questions? Before we go on. Yeah, another question is, do you all guys have the same 76.25?
Yep.
So because it's
Yes.
important before we continue that everybody has 76.25. All right. Then if you do have 76.25, then there is an exercise. And this is a big exercise, a challenge, a big challenge. Let me first explain a little bit of what is it that I want to do. So we have 3 models, and we have a validation set, right? And we have a training set, obviously. So we trained our models on the training data, and then we predict a validation data. What I want to do, I want to visualize so-called decision boundaries. Do you guys know what decision boundaries are?
Yeah.
Oleg, what are decision boundaries?
Decision, to be honest, maybe I know, but
you probably know,
term.
but it's maybe it's a term that is new. Lena, what do you think you know what a decision boundary is? I mean, what I understand that you guys are not familiar, but maybe you can guess what they mean. There is no right or wrong in that sense. So don't worry about this. Just say something. Kenneth, you had some ideas what decision boundaries are.
Yeah, it's a line which if you move like a tiny direction from one way or another, you choose A or B. It's the piece of the mountain.
Yeah, and even visualized. Nice. What I actually want is not just the boundary itself, but the map, decision map. So look at this validation set here. I want to know what class would be assigned to a point, to arbitrary point that would appear on this square. Okay? So what I want is that I want to see a color that would correspond to a class to arbitrary point in anywhere on this square. Do you understand what I want to do? So there are 3 classifiers. I want to do it for each classifier separately. And I want to visualize a decision map. The decision map will tell me what would be the class assigned to a point that would appear in arbitrary location on this square, on this in this world, and this coordinates. Does this make sense? Simeon, do you understand what I want?
Yeah, I understand.
Okay, so let me try to explain how do I want to get there. I want you to try to make a function that generates a synthetic 2D point grid that spans from start to stop along x1 and x2 dimensions. You should be able to specify the number of points per unit of distance. So it may be your grid could be sparse, or your grid could be dense. You should be able to specify how dense or sparse your grid should be. For example, here's an example. If there would be one dimension, so we wouldn't have 2-dimensional point grid, but just 1-dimensional point grid, that would span from 0 to 2 with 3 points per unit, which is like 0 to 1 is 1 unit. So there are 3 points inside this unit. You would need to create a vector 0, 0.4, 0.8, 1.2, 1.6, 2. And you can create this output using function np lean space. And you should do it for 2D. Right, so what I want here is that I want to have a grid. I want you to create a grid from -2 to 3 along each of the axes so that I can cover up the entire space, the entire square, cover up with the grid. And then I can predict a class for each point in this grid, and I can color them according to this class. So I could see what classifiers do, not just calculate what they do, but also see what they do. Seeing is believing. That's what we are saying in computer vision. So in computer vision, we are saying seeing is believing, and that's why I want to see what the classifiers do. And your guys' task and your challenge is to make a function that would do exactly this. So the function is here. Your code should be here. And once you're ready, you can test it. You can test it with this cell. So if I run, if I do something like 0, and I run this cell, the function, I get some error because, well, basically this doesn't have any shape. Well, I can make it a shape. Well, still doesn't have shape. But anyway, so it should give you, this result should give you a shape of number of points squared, which is number of points is, I calculate here, this is number of points, and 2. This would be the shape of the grid. So ask me questions and give it a try. Try to create a grid that would span, that would cover up the entire space, which I can later predict with my classifiers, and I can visualize how the classifiers work. Try this out. Challenge yourself. So see if you understand what I mean.
Yeah. So to make a grid, you mean make a series of coordinates? Is that?
Yeah.
Yep.
Yeah.
Make a series of coordinates that then we can make predictions on, and then color.
Yeah.
All right.
Lena, ask questions. You look terrified, but you shouldn't be. So how do you approach these kind of things? So you guys, You can do it in parallel. I'll just show how would I approach this problem. First, I would ask myself, do I understand what I want? Lena, do you understand what you want?
Okay, I understand in theory, but I don't understand how to apply it at all. So I don't know how even start.
But what is the theory tells you? What is it that you want?
That you have, I don't know, canvas, and you need to.
Yeah, exactly. Right. So you have a canvas, and you want to do what with this canvas?
Like, for example, if you have linear regression, it will be line, and for example, like if it will be 0, it will be, I don't know, blue color, and if it will be 1, it will be red color for all this shape.
Yeah.
Yes, something like this.
Something like this. So let's look at this graph again, right? So what I want is to create points with 2D coordinates. Let's just pretend that these coordinates are -2, -2. What is it here? -2, -1.5. Okay, let's make it even more sparse. -2, -2, -2, -1, -2, -0. Okay, what if I make it even simpler? What if can you create a grid of points like this? Just 4 points. Wow, okay, 4 points. -2, -2, -2, -2, -2, -2, and then 2, -2, and 2, 2. Only 4 points. So this would be just 4 points, data set that would contain just 4 points, right? And then I could classify them, and I would know what would be the classes of this corner cases, right? If I would classify them with my classifier, then I would know what the classes of the corner cases. And then we can, if you can create this kind of grid, we can make it denser. So we can make more points in between, right? Think about creating just 4 points. -2, -2, -2, 2, 2, -2, and 2, 2. The practical part is, of course, hard. How do you create that kind of stuff, right?
That's like plot something, plot a point, step it up by the interval, plot another point, step it by the interval.
Yeah, but you need to create a data frame or a NumPy array for that sake that is just point coordinates. So not plotting them before for now, but just coordinates. So you need to have as many rows as there will be points in the grid, in this final grid data.
I don't feel prepared to even begin to solve this.
Yeah, that's yeah. So let me try to help with that.
But earlier on, have we talked about how to plot something?
Yeah. So let me take just this one function here. This function makes equal intervals of values from 0 to 2, and the number of points is this. Okay, so let me even do it like this. So okay, here we go. So let's recreate the initial example, right? So I start from 0, I stop at 2. I want to have 3 points per unit. Okay. And now I can have this stuff. All right. So this is what my 1D grid would look like. This is what my 1D grid would look like. Okay. If I want to have 2D points, it means that for each one of these values, I would need to have another value. So they would be, this would be 1 dimension, but I need also the other dimension. Let's create this grid data, and let's make it a data frame. Let's call these guys X. Okay. Okay. This is not how you create it. This is how you create it. Okay. So then I can do this, and you can see what I mean. Okay. This is X. Okay. Now, what happens if I say grid data y, or let's say y equals to, and then the same function. So what do I get, Lena, in this case? If I create a new column y, and then I print out the results. So currently grid data frame looks like this. Mm-hmm. It has 1 column X and it has 6 values. Then what I do is I just create another column called mm-hmm. Y, and I assign the same values. How my data frame would look like?
Like you will have the same data frame with Y column?
With a Y column, yeah. Which would have the same values. Okay. Now, what I want you guys, I just want to take, let's say, I want to create another. I want to create another column, which would be called model 1. And I would use my model 1, which was, what was the model 1, Oleg?
Model 1? You mean which classifier we used?
Yeah, yeah.
I need to look. Model
so there were
1.
3.
Decision tree, I think.
Yeah, it was a decision tree. Okay, I made a mistake. It's not supposed to be X and Y. It's supposed to be X1 and X2. I'm sorry, guys, but I'm really sorry. So this would be X1 and X2. Okay, just not X and Y, but just X1 and X2. The same stuff, but just different names. Okay. Lena, now that I want to use decision tree to predict a class of the synthetic points, mm-hmm. what should I type inside the brackets here?
Fit, no?
No, I already used predict function, so it's a function is there. What should it predict based on what?
Okay, X.
Kenneth, what should I type in there?
Predict the X1, X2. So predict based on that we just generated.
Yeah. Or so what I want to do is I want to predict X1 and X2. So I take this as my input data into my classifier, right? And what it does, it predicts a class, right? So do you guys understand this part? Sure. So I just generated synthetic data, some absolutely out of blue. No idea, just out of blue. And I predict class for these points. Hey. Oleg, do you understand what I do here?
Yeah, sure.
Simon? So what I do? Can you guys explain to me what I do?
You try to predict the class for these points.
I try to predict class for these points. Can I actually do it? Like I really, these were not points from my validation. These were not points from my training. These are like randomly generated stuff from nowhere. Can I actually do it, Kenneth?
It doesn't. I mean, it's not linked back to our original models. I don't think. I don't see the connection.
What do you mean by link back to original models? What do you mean by that?
So I mean, so model one is the trained model based on our original data, correct? Right?
Yeah. Yeah.
But
can I predict these kind of absolutely points from nowhere?
Presumably they'll be, yeah, yes. I mean, it's classification. It has to be one or the other. Like there's not.
Yeah,
I mean,
what's the problem, right?
Yeah, there's not much predicting to do. It's either 0 or 1 kind of a thing.
Yeah, it's just gonna do something, right?
Yeah.
All right. So I predict, and if I would visualize my grid data, here would be my grid data. So I get 0 for the first point, and I get 1, 1, 1, 1, 1 for the other points. So what happens is that I take I draw my validation set. So please follow attentively to what I do here, because that's what explains that's what explains what I do, why I do what I do. So I draw my validation set. This is my regular validation set, nothing to do with this stuff that we have done. And then what I do, sorry, this is not supposed to be there. So what I do, I add points from the grid data. And I color them according to classes predicted by model number 1. I make them small and I make them transparent. And probably you won't even see them because they are above the main points. Yeah, no, you can see them. Here is it. Can you see this?
Yeah.
Yes.
I can make them bigger and you can see them more clearly. Yeah, so I can make it 5, let's say. So you can see them more clearly, right? Now, if I make a grid denser, I actually make a grid, meaning that I will have the entire space covered with this little thingies, and they would overlap one on top of the other. I would actually see which points get which class in arbitrary locations of the grid, right?
Yeah.
So I would visualize what my classifier think about not just these points. I can color these points in whatever classes I want, but I would also see what happens outside of these points. I would see what happens in other places, right? Where my validation set is not reaching out.
Yeah, I mean,
you understood this point, but you didn't understand how to get started with the coding part.
Yeah, I mean, like the task, like in words, the task is simple: predict everywhere, predict at every point, make a prediction, and then color it. It's the thing that I feel not prepared for is to like how to make that turn.
How to make it actually work. I got it. All right, I got it. How do I make it? How do I actually make it work? So let's say that I really want to cover up the entire space from -2 to what are the original ones? Okay, -3 to 4, and I want to have 20 points per unit. Okay, 20 points per unit. So just to cover up one row, let's think that I'm just thinking about one row, one little row here. I would use this function that we have used, this one, right? First, of course, I would need to calculate the number of points. Can you guys predict how many points do I get? So I get start to stop times 20, right? So it's 3 plus 4 times 20. This is how many points I get. Okay, So this is 140. Oleg, what is this 140? Number of points, I understand, but where they would be located. So
number of points
in the grid in one line, right?
In one line,
row.
it's our x, yeah, let's say, yeah. So it's
one row. For example, it would be somewhere at this location at -2. So this would be one row of points. 140. How many rows do I have in this grid? Ladies and gentlemen, this is a $100 question. How many rows do I have in this grid? Simon?
140.
Hey, that's a square. If you have one row of length 140, then the other one is also 140. So how many points do I get in here? Lena, how many points do I get inside the entire grid of square of 140 and 140?
140 power 2.
Exactly.
2,600.
I get 140 times 140, which is 19,600. This is an entire number of grids. All right, that's fine. That's fun. That's okay. But how do we get there? Please. We are fed up with all this kind of walking around and not really doing the right stuff, right? So let's start with start and let's end at stop. This would be stop, and this would be the number of points. Now, for each one of these 140 points, I should generate the same. So imagine that I start with the lowest row. I generate these points. These would be my x-axis. But for each one of them, I should generate 140 points with the same x-axis but different y-axis, right? So for -3, the point with the x -3, which is somewhere here, I should generate 140 points, which would have x value of -3, but different y value, right? And that y value would range from -3 to 4, right? So how do I do it? I do something like this. I do list comprehension. I know that you guys don't like list comprehensions, but this is how I basically end up doing this. Let me think. So I take this, for example, -3, x in whatever. This would be x1 in. So I take this x1. And then what I do is I create, so this would be a 4 x1 in this sequence. So for each one of these values, I will do something. So this is where I do something.
Predict.
Something. So what should I do to get a 2 columns, x1 and x2? I would create a data frame. I would create a data frame. I would create a data frame which would have x1, and by the way, it would be like this. And then it would have comma x2. So what kind of what is inside here? I think it gets a little hard to follow on this. So let me you know what? Let me stop this for now. I'll just I'll just resume sharing. This. So basically, I will just plot it right here. This would be the list comprehension that I'm looking for. I would repeat x, this x from this line space as many times as there are points that I'm looking for, and x2 would be just the same line space. Because for each x, I would need to have the same x and the line space of x2. And then I would concatenate all these data frames into one data frame. That would be my, I would share it with you guys in chat.
Yeah, please do. So this
And
function,
this,
what does that do?
sorry?
Function repeat?
Repeat just repeats the values as many times as I want them to be. So this is the value that it repeats as many times as I'm saying that they should be repeated.
Okay.
And if you run this, you get 19,600 times 2. This is the grid that I want. Ask me questions about this. I know it's, this is the hard part. I actually, myself, I think it took me some time before I could formulate it like this. I think there is a simpler way to get the grid, but it also requires knowing some other functions of Python, which are not, to my knowledge, are not so easy either. So it's either one or the other. I prefer to create it myself, but there are other things like mesh, I think in Python that you can create mesh. But
does that cell work? I got an error trying to do that.
to me, yes.
Can you perhaps paste it into
Slack?
And,
Yeah, sure. I'll paste the entire cell.
Yeah, I think
I'll paste it the entire cell. Okay. The cell is in the Slack. Do you guys have questions about this? I know, it's hard. This is a hard Python, so I don't expect to really understand the depth of it. I expect you guys to run it and
second, 19,602. Good. Yeah. I don't have questions. I just, I believe that I could be able to do this. I just don't believe that I am yet have been prepared to know how to do this. That's all.
I think Dmitry is frozen again.
Me is frozen because I'm stuck.
so did you have a chance to vent a bit?
No.
Yeah, so can you please use these models, ensemble, model 1, model 2, model 3, to predict all the grid points? And raise your hand as soon as you're done. And ask me questions in the meantime. This is, I would tell you that this function is the hardest programming exercise in the entire practice. There is nothing harder, including your homeworks. And homeworks are not so much about programming, but rather about understanding machine learning. Done? Simon, done? Yeah, raise your hands if you're done, so that I know that you guys are good. Elena, you done? Elena? Okay, so yeah, so I just write model 1, predict. Igor, are you around?
I don't know. I just copy pasted this model 1 predict well and square bracket is 1x2.
But we want to predict grid data, not val, not validation data. But so what would be the difference? So you had before this kind of stuff, right? X1 and then X2. But now instead of val, we need actually grid data, right? So the only difference is that the name of this thing.
Yep.
And then I would just do it for the model 2 and model 3. What should I do for the ensemble? Ladies and gentlemen, what should I do for the ensemble?
Mode.
Mode, yeah. So, but what should I type? Grid data. Simone, I can't hear you, you're muted.
Yeah, so model 1, model 2, model 3 as columns.
Was it double brackets or single brackets?
Yeah, double brackets.
1, model 2, and model 3. Lena, what else inside mode? Sorry, what is inside mode? Can I leave it like this? Lena? If you just go up at the place where we got the ensemble, you can see it for yourself. All the questions that I ask, they've been asked before, or they might be asked before. So there is almost nothing new in here. X is equals to 1. So I can run this. I will copy it to Slack just in case. Yep. Okay, now we can finally visualize stuff, right? So let's visualize the prediction boundaries of the first model, which was a decision tree model. All right. This is the way how the decision tree boundaries look like. How can you interpret this? Kenneth, how can you interpret this?
Well, how can I interpret this? Everywhere that it's blue is going to be predicted to be class 1. Everywhere it's red is shaded, it's going to be predicted to be class 0. And the actual boundary line is kind of obscure. It doesn't look like it's contiguous. It looks like there's some isolated islands.
Mm-hmm.
But it's not strictly a boundary. Yeah.
Yeah, it's not a boundary. It's there are islands, and there are weird kind of lines here and there. We can see that most of the points are classified correctly. I guess most of the red points are in the red. There are some points that are on the red that are blue. Most of the blue points are in the blue, which is kind of nice. Let's see what the second model, which was K nearest neighbor, has to say about the decision boundary. Okay, this looks much more well, less angular, less more smooth, right? Still, most of the kind of big fraction of points is classified correctly. Still seems like blue is on the blue and red is on the red, but some kind of weird shapes here and this kind of stuff. You can also go on for the logistic regression. Igor, what do you expect for the logistic regression? How the decision boundary for the logistic regression would look like? Would it be more like this, or it would be more like this?
For logistic, I think there should be no islands. So I think it should be more like,
more smooth or more like this? More like.
I think more smooth.
More smooth.
I don't know, but I think, yeah.
Okay. Okay. Kenneth, what do you think? What would be the decision boundary for the logistic regression?
Well, logistics is a line, so it'll be a line.
Yeah, it would be a line. So it would be quite smooth, but it would be a line. It would be like this. And the ensemble. So what do you guys think it's going to be? So what would be the ensemble? It's a combination of all these three, right? So it's a combination of three. It would be a smooth version with some angles of all the previous ones, right? That's what the ensemble looks like. If you look at the ensemble, that's how it looks like. Well, it turns out that scikit-learn has a voting classifier, has a majority voting classifier. So it has an ensemble with a majority vote. It's called voting classifier. You can import voting classifier from scikit-learn ensemble, and you could take your models, all these models, model number 1, model number 2, model number 3. You can add names to these models, like a decision tree, TNN, LR, and so on. And you can say hard voting, which means that it's not about probabilities. Simon, remember you said in the beginning that if the classifier is producing probabilities, it can take averages. So voting equals hard means that they produce classes. So there is no way you can do probabilities. It's all about modes. Okay. And then you fit this ensemble model from the scikit-learn on your train X and X2, as you normally do for any model in scikit-learn. You predict using predict function on validation data, as we usually did. And then you take a ensemble score, which is 76.25, as we calculated before.
Will voting classifier do multi-classification or no?
Yeah, it could do multi-class classification as well. Okay. It could do multi-class as well. In fact, you can find voting regressor, and you could do regression on these things. And then you could, and this is just to compare that this is what we have calculated before, and this is what the scikit-learn implementation provides, right? So they are identical. They are absolutely the same. Please ask me questions about the voting classifier in scikit-learn.
Looks cool.
Oh, we have been suffering quite enough, and this is just the way how it looks. Of course, we can visualize it, but something tells me that the decision boundary, will be the same for the voting classifier as it is for the handmade voting classifier. This is the ensemble, right? Voting classifier. When I say voting classifier, I mean ensemble. In this very particular case, this is ensemble. Do you have questions or comments about this?
I have a question about this part of code. We specify model 1, model 2, and model 3. Yeah. And why we should specify the method next to the model?
No. I think you can write whatever you like.
Okay.
Best model ever, and I think it will still work. So yeah, it's just a name. So I just left it for myself to know what the names are. Any other questions about this? I guess we are all tired, and I can see a dawn on the background, Elena's background. There is a sun is actually rising. You know what? That in Tartu we have white nights, so sun almost never goes down. We always have light, even in the darkest hour. Right. Let me get back to the lecture slides. And so this was the, so this is where we stopped at the message that not all models are born equal. So currently, so far, we have been working with models on a very equal basis. We were egalitarian. We were very egalitarian. So we were using models with equal rights. So every model has equal rights in our ensemble so far, but it's not always the case. It's not always the case. Not always all models have the same rights. So how does it work? This is what we have seen before, majority vote. Each model had the same right, equal weight for each model. But are they actually equally useful? Are these models equally useful? We don't know. We don't know if they're equally useful, but there is a way to find out if they are. We cannot use test set to estimate their performance. How can we, okay, everybody, what is the way to find out which model is more useful?
Accuracy.
Without using test set. Kenneth, you were saying?
Just accuracy. You could, if I was going to do it, my first guess would be to weight things by their accuracy.
Yeah, but where do you get this accuracy? Accuracy on what? On the training data, but that's overfitting. On validation data, well, then you are overfitting to your validation data.
Well, I mean, that's the only data that's left, unless we make a new form of data.
Okay, okay. Anybody? What do you think? How could you estimate the usefulness of each model without really overfitting to validation or test set? Oleg?
To predict on the test set?
You can't do test set because you will then mark the test set. That test set will be not that it will be unuseful, but your final ensemble performance will be more optimistic on your test set than it's supposed to be. So what's the other? There is an algorithm for this. What kind of algorithm? We studied.
You mean cross-validation?
Yeah. So you guys had the silver bullet. So at least Lena should have shot the silver bullet saying cross-validation. Should use your cross-validation here. So we can do cross-validation on training data. So we take a model, we split our data into folds, fold 1, fold 2, fold 3, and then we just feed 2 folds, for example, into the model. We train the model on 2 folds, on other 2 folds, on third 2 folds, and then we predict it on the validation set, right? We get some scores, right? Score 1, score 2, score 3. For example, we got something like 0.75, 0.7, 0.65. We take the average, we average them up, and we do it for all 3 models, for all the other models, okay? Well, we can say that model number 2 is more important than other models, and model number 1 is more important than the third model, which is in useful knowledge. What we could do, we could just normalize these scores so that they sum up to 1. How do we normalize the scores so that they sum up to 1? Igor, how do we normalize the scores?
To normalize, we can weight them up.
We can do what?
I think, how to say, I don't know, weight them, no? Just add, obtain sum, then
Sum
get-
and divide by number of basically by number of them, right? So we
Yeah.
just say sum and divide by 3. Right? So, well, you divide each one of them by the sum. Sorry.
so yeah, it's what they call weight to them. Like,
Yeah, so now they would sum up to 1, right? So 0.33, 0.37, 0.3, right? So we can relative weights. And now we can use these weights, right, to weight the model predictions. So how does it really work? What does it actually mean, right? So how do you weight them? Imagine that you have a parliament. You have Верховна Rada. And in this Верховна Rada, there are, how do you call them? Vultures. Somebody with a fluent English, how do you call people in Rada? Deputies, yeah? Do you call them deputies or?
Members of parliament, they're called in Canada.
Members of parliament. Yeah, let's use members of parliament. Sounds more professional. So members of parliament, and they belong to parties. There are 3 parties. So each party is represented by model number 1, model number 2, and model number 3. There are as many members of the parliament as there are seats that are dedicated to each of the models. So for example, so these are representatives. I use word representatives of each model. So there is an entire parliament, okay? And it's divided between 3 models, so 3 parties divide the parliament. There are 33 seats that belong to the first party, the first model, 37 seats that belong to the second model, and 30 seats that are taken by the representatives of the third model. So when the parliament makes as a decision-making body, right? They make decisions based on the majority. So there are 100 seats in total. Each representative vote as their party. So the party votes uniformly. Everybody votes the same thing as the party votes. And then we just count how many people voted for each of the decisions. So for example, we show to Верховна Rada on their screen, we show a picture of a dog. And then we basically ask every member, what is the picture? What is the class of the picture? And some of them say it's a dog. Some of them say it's a cat. What happens is that previously we had just 1 vote from each party. So each party had just 1 vote, dog, dog, cat. And then we would just take a majority vote. Now we have a different picture. Now we have first party having 33 votes, second party 37 votes, and 30 votes by the third party. And now we can sum them up. And this is 70 votes for dog and 30 for cat, right? So that's how the weighted ensemble is different from the non-weighted ensemble. Previously, each model had just 1 vote. Now it's a different number of votes for each model, right? It doesn't change things. The outcome remains the same in this very particular case. But think about the situation when you have 3 classes instead of 2. For example, we have dog, cat, and rabbit. For example, in the case of a basic ensemble, we have first model voting for the rabbit, second model voting for a dog, and third model waiting for we would vote for the cat. Kenneth, what happens in this case when each model votes for the different class?
It's a hung parliament, no decision.
Yeah. But what would be the final decision?
I don't know, nothing.
No, they still should make a decision.
I think whose weight is bigger, yeah?
No, but in this very particular case, it's a draw. So they would have to do a random choice. They would have to toss a coin. Well, instead of the coin, they would have to roll a die with the 3 sides, right? Because there is no coin that would be enough for this case. But for the second case, you can say, well, the dog wins, right? Because the second model is definitely more important than the other 2 models. So we can
This
say
is
that
exactly
the dog wins.
what I meant, yeah.
Yeah,
that the bigger weight, yeah.
Yeah. I was asking about the basic ensemble. So what happens in the basic ensemble? In the basic ensemble, they choose by random choice. They just go for the random.org, and they say, I want a dog, cat, or a rabbit, and that would choose rabbit, dog, or cat. But in the second case, you don't need a random.org. You can actually decide based on the votes. Do you guys have questions about this? Lena, do you understand what's happening here?
Yes, but if you have more than 50%, so we don't need to use all three models, that our one models will be major way. I don't know how to explain this.
I think I got it. So the question is, if one of the models is above 50%, right? So it doesn't really matter what happens if the two other models are even if the two other models are voting against this one model, it's basically not useful because the decision by the first model will overrun the other two. Well, that's a very bad case. This is a not useful ensemble because you won't use actually predictions by other two models. So usually you wouldn't end up with that kind of situation, because if you would have that kind of situation, it would mean that your one model actually makes sense and the other two do not make much sense. So it doesn't make sense to listen to these other models. Yeah, in that case, it wouldn't make much sense. But for the binary case, but even if you work for like multi-class classification, yeah, I can't really come up with a good use case right now, but I think this would be not very useful ensemble. Let's put it this way. I'm not sure if they happen in reality like this. Maybe, could be that you're right, and this would be not very useful ensemble. Any other questions? Okay. Yeah, this is just a quote from Churchill. Democracy is the worst form of government except all of those that we have tried before. And basically ensembles, they show that these are so far the best ways, although they're not perfect. Here I just explain how the same things work for the regression case. So how does this weighted ensemble works for the regression? It's actually pretty simple. You get 3 regressions, you average their predictions. So this is how normal ensemble work. You take a prediction by each model, you average them up, and this is how you get the ensemble, right? What it means is that you actually have equal weight on the prediction of each model, right? So you have 1/3, 1/3, and 1/3 for each model if you have 3 models. If you would have 4 models, you will have 1/4, 1/4, 1/4, and 1/4. In the case of weighted ensemble, yeah, these are equal weights. In the case of weighted ensemble, you could use some weights, for example, these kind of weights, right? Then instead of using 1/3, you would use a 0.32 multiplied by the prediction, 0.32 multiplied by the other, and then, for example, 0.36, if you would trust this model more than you would trust the other models. And this is called weighted ensemble, right? So you take the value of X, this is the prediction by the linear regression. You multiply it with the coefficient, you multiply the ridge regression prediction with the coefficient, and so on. And then you would get weighted ensemble prediction for both points, right? This is what weighted ensemble for the regression looks like. Do you guys have questions about this? Any questions about that? Okay. Another way to look at it is that you have the parliament, and then you have, out of 100 representatives, you have 32 for the linear regression, and then you just multiply the prediction by the proportion of representatives in the parliament. Right? So these are the same things. Yeah, that's this part of the lecture. I know that everybody is tired. I'm thinking I'm thinking that it doesn't make really much sense to start with the next part of the practice session, because I think we are all pretty tired and there is a lot of new stuff. Well, not so much, but still some. I propose that we stop here and we move it for tomorrow. And tomorrow we'll go through the rest of the practice session and the rest of the lecture. There is actually a lot of other things left, but we can try to finish as much as we have. And for now on, I'm happy to talk to those of you guys who have questions about the homework. So I'll stop it here. Let's call it a day. And I'm happy to answer questions about homeworks, because I know that you guys have questions about homeworks. Homework number 1. So for now, questions about this part of the lecture, about weighted ensemble. So far we haven't practiced it. We will do it tomorrow on MNIST data first. We'll start with MNIST data. We'll train the models, and then we'll see how the normal ensemble works and how to make it into weighted ensemble. How do you take a normal ensemble and then you make it into weighted ensemble. Then we will finally together implement a cross-validation algorithm by ourselves. Then we'll see how you can do it with a scikit-learn function called stratified k-fold. And yeah, we will go on like this. Questions? I think 4 hours is it's a hard format. I think initially the plan was to have 4 hours plus 4 hours, 3 days in a row. I think our brains have melted after one time 4 hours. I can't imagine what happens to you guys when you have like 36 hours. Oh.
Yeah, we'll have another class in an hour or so.
Go ahead. Okay, sure. I just so yeah, everybody is free to go. It's just I'm here to stay with you that who want to ask questions about the homework.
Well, actually, may I suggest this? Maybe if it is possible, I don't know. Maybe we could have like 1 hour in well, maybe not now, but
Okay.
maybe next day, just because actually I've tried to complete this homework, first homework, and actually I didn't manage because of as far as I get, the same reasons why other guys did not complete, because maybe I don't know kind of a function in a Python just to do what has to be done, because algorithmically it's really well it's clear and it is understood, but how to make this code to work and to do what you need that was a challenge for me. Okay,
let's do it like this. Tomorrow after the lecture we still need lunch, I guess. So would it make sense to like have a break after the main lecture and then discuss the homework?
That would be a greater idea than to do it now, because now it's Friday and Friday is
still work day.
Still work day, yeah. So
yeah. Okay, let's do it then tomorrow. Okay, makes sense. Okay.
This for me. Thanks.
Okay, gotcha.
Like 2 to 3 p.m. tomorrow, kind of thing.
Yeah, something like this. Okay.
Okay. All right.
Good. That's good. Mm-hmm. Anybody else? Any other questions? Anything that you guys want to discuss? Yeah. By the way, just before you guys detach, just wanted to say I will not grade correctness. I will be grading the effort. So that's just what I wanted to say, is that I will be probably grading attempt than the final performance. So if I see enough attempt, enough effort, I can grade it. It's a normal practice. So just one thing that I need is that I want to see effort, and your point would be to somehow document your effort, to make it clear what you have done and what didn't work, right? So you could say that I have tried this, and that, and it still didn't work. So I didn't get how do I make that thing works, and it's still, yeah.
Yeah, my one question is maybe to return to the question I asked at the very beginning, is there a resource other than just searching Stack Overflow?
No.
Is Stack Overflow less the one that everybody uses? Okay, all right.
That's what programmers do. They do not do programming, they do Stack Overflow. So normally that's how it's done. You go just for a Stack Overflow, and yeah, unfortunately there are lots of trash up there that doesn't work, or it's not supposed to work. But that's how it usually works. Okay, get some rest. See you tomorrow at 9 o'clock, and then we'll have a discussion about the homework. Good luck. Have a nice second part of the day.
Thanks so much, yeah.
See ya.
Yeah.
Thank you.
Thank you.
Bye-bye.
Bye.